Friends, today we'll study about the most important and fundamental topic of matrix algebra, that is matrix multiplication. So let us begin with it. Let us assume a matrix A of the order m cross n, which means it has m number of rows and n number of columns. Let us assume another matrix B that has whose order is p cross q, which means it has p number of rows and q number of columns. Matrix multiplication of these two matrices A and B is only possible if n equals to p, which means number of columns of the first matrix is equal to number of rows of the second matrix. Also, the resultant matrix that we obtain after multiplying A and B matrices is of the order m cross q. Now I will illustrate matrix multiplication using a few examples. Example number 1. Let us assume two matrices A. First one is A. 1, 2, 3. The order of this matrix is 1 cross 3. The second matrix B is 1, 3. The order of this matrix is 3 cross 1. Okay. So the first basic condition, that the number of columns of the first matrix should be equal to number of rows of the second matrix, is met, and the resultant matrix that we'll obtain will be of the order 1 cross 1 as mentioned above. Now I'll show you how to multiply these two matrices. Here we will multiply the first element of the first row of the first matrix with the first element of the first column of second matrix. 1. Also, next step, we'll multiply the second element of the first row of first matrix with the second element of first column of the second matrix. And similarly, 3 into 3, 9. We add these individual products, and our resultant matrix A and B, which is supposed to be of order 1 cross 1, is 9 plus 4, 13 plus 1, 14. Let us take a bigger example. Let A be a matrix of order 3 cross 3 and B be a matrix of order 3 cross 3. The basic condition that the number of columns of the first matrix and the number of rows of the second matrix is met. 3 is equal to 3 and the resultant matrix will be of 3 cross 3 order. So our A matrix is 1, 2, 3, 4, 5, 6, 7, 8, 9. Our second matrix B, I will assume to be the identity matrix of order 3, which is 1, 0, 0, 0, 1, 0 and 0, 0, 1. To multiply these matrices, we shall follow the same steps as we did in our first example. Let us begin. Again, we will multiply the first element of the first row of the first matrix with the first element of the first column of the second matrix. 1 into 1, that is 1. Now, for the second entry of the first row of the first matrix and second entry of the first column of the second matrix, we add these individual products. Now again, and for the second row with the first column here, so our final result AB matrix will be 1, 2, 3, 4, 5, 6, 7, 8, 9, which is equal to A. This also illustrates a property that if any matrix X is multiplied with the identity, then we obtain X. Thank you, friends.